Oh, damn, it's really cold. Hey, this is Jonathan. And yeah, it's really freaking cold these days. I don't know why it's so cold. Well, I mean, it's getting close to winter, so I know why it's getting cold. It's just it got cold surprisingly fast, and I kind of didn't really expect it to get at least this cold in my room. But hey, I mean, I totally should have seen that coming. I'm just bad. So last time I forged ahead, made a bunch of progress, and that was pretty cool. I can actually concentrate on different issues now. I think first of all, like I said last time, I want to concentrate on getting systems running on a per state basis, but doing so is probably going to be a bit difficult, I imagine. Like, I don't think it'll be like super straightforward to be able to figure out, because I don't think the documentation on that is, well, particularly plentiful, at least from what I've seen just poking around. But I know it should be possible, so yeah, I'll just have to figure it out somehow. I think it has something to do with the either state data or game data, one of those. So I guess we'll first start by poking around in maybe the book. I think the book is a good place to start. So yeah, I'm not really expecting to get really far today. Like, I expect today mostly to be just poking around documentation, doing research, and hopefully I will discover what I need to discover in order to make what I need to make happen. But it's gonna be a process, I'm sure. At least I have some direction in, or I have an idea of where to go, kind of. And in a worst case scenario, I can always look at the source code, which is always available. That's the really nice thing about having the engine be open source like this, is you can actually read through their code and you can kind of understand like what's going on. Yeah, so here they actually transition between a pause state and an unpaused state, I guess. But they use they just use handle event. And here they just have unit as their state data. There must be something about this in either system or dispatcher. All systems are run by the engine together, even in parallel, when possible. I don't know when it determines when it cannot do run systems in parallel. I guess it must have some way of waiting when it requires data. I'm sure there's some mechanism in which it does that through, like, I don't know, futures or something. But yeah, it is kind of interesting, because sometimes systems will be dependent on each other. But yeah, I think that it tries to, like, by default run all systems in parallel, if I remember correctly. I could be entirely wrong, but yeah, that's what I remember. I'm pretty sure the dispatcher tries to dispatch all threads in parallel by default. Context of the game. Okay. One to carry information access to multiple systems. Data local to a system is usually stored in the system struct itself instead. Okay. Yeah, that makes sense. Ah, here we go. Huh. So read is good for when you have defaults. Read expect is for when you don't have a default implementation. We know what read storage does. And entities, that's something else. The create or destroy entities in the context of a system. Okay, that sounds very interesting, because I might need entities in order to delete the old buttons from the previous state. It's like, so I can actually, clean up after myself, I guess, is a better way of putting it. It kind of sucks that there isn't really like a way of knowing which entities belong to a certain state, so you can't just like do a mass, delete all the entities from this state. Or at least like mark them for deletion easily. I mean, there must be a way of doing that, but it's, I don't know it off the top of my head. And there doesn't seem to be like a... Well, I haven't read the documentation, so I'm probably just, saying dumb stuff. But from what I know, there isn't a way of just easily deleting all the entities from a state. Maybe that's a good thing, but it sure seems less convenient to me when you're trying to, just switch from one state to another and not carry over a lot of stuff. Mind you, there is stuff that you will want to carry over, typically, like options from your options menu. So I suppose it is true that you might want to actually keep stuff, or at least some stuff, in the majority of cases. Transforms are common, that's cool. Represents a position, rotation, and scale, huh? Alright. I mean, I did get a UI transform earlier, and that was important. Look at this. All this unwrap usage in their examples. Teaching people bad habits. Well, I think it's kind of implied that you're not supposed to do that, but at the same time, like a beginner who just sees this and they don't know anything about Rust is just gonna jump in and think, oh yeah, unwraps are fine. I don't know. I'm a kind of a stickler when it comes to, unwraps. To be completely fair, I come from a Scala background, and in Scala they have both null and option. And the thing about that, so the null is there because of compatibility reasons. It's there to be compatible with Java. But I've seen other people just utterly abuse null as if like you should also use null at the same time as you're using options. And it's like no. Like you're typically supposed to replace null with options, but they just like use it all over the place. Not even just for like interop with Java. And sure enough, you run into ye old null pointer exception and whatnot. So yeah, just that kind of abuse of, I guess, null / option is kind of why I feel like people should be more careful about these things than they are. But those are my 2 pennies. It's probably not worth anything. So, getting all the entity-specific components is okay. Well, maybe that could help. I don't know. Okay. So a join is to get to get entities that have all those components, not just some of them. So that's kind of interesting. It's an AND gate. Yeah. Okay. That's what I figured. It works like an AND gate if you know what an AND gate is. I hope you know what an AND gate is. To be fair, I guess most people would know what an AND gate is. If they've done any, like, if they've taken any, like, courses in, like, university or whatever, college, I'm sure that they would teach you about AND gates, but I feel like this is definitely geared at people who have at least some programming experience. And to be fair, people who don't have any experience at all probably wouldn't be able to understand this engine at all anyway. Creating new entities in a system. Yeah, I know how to do that, I think. Yeah, you can use this entity builder thing. That's cool, I guess. System data. Why would you want to do this? Now I have to wonder what the purpose of this is. This is definitely not a good example of why you would want to use it, I feel. But data.bas.should process. Yeah, I don't really understand why you'd want to do it this way. This seems a little bit, I don't know, like a contrived example. It doesn't clearly illustrate to me why you would ever want to do this, because it says that while this is rarely useful, like I understand that they're kind of downplaying the importance of knowing this, but it would be nice to see like an example of where it is rarely useful. So yeah, that page didn't really look like it would be useful. So I was kind of expecting this page to be more useful, but this page is literally this. I can't scroll up or down. Yep. Dispatchers are the heart of the ECS infrastructure, but where do you put your dispatchers? Oh no. This isn't what it will execute. It generates an execution plan. Huh, okay. Okay, good to know. We prefer immutable over mutable whenever it is possible, which is, you know, I feel like that's a good rule in general. Except for those places where mutation actually makes things faster. And this is also important to know, but this doesn't tell me about dispatching events per thing. This chapter will be easier than the previous ones. And then they immediately say that it's not essential to understand it. What? Works best when used with only a single thing, usually a system producing events. The event channel should be stored in a global resource for ease of access. What? Really? Okay. Okay, to be able to track where each of the receiver's reading is at. What? that phrase right there. That is not really easy to read. Oh boy. Is he aware of their presence? This is done by registering reader ID. Okay. Sure. Keep track of where your last read was. EventChannel automatically grows as events are added to it and only decreases in size once all readers have read through the older events. Oh, so if you create a reader ID but don't read from it on each frame, the EventChannel will start to consume more and more memory. Good to know. Now I am not so sure about that code I wrote last time with the reader event. This one. Because I have an event channel here, but I think they said the event channel should be like global. So that's interesting. I do read from it on every frame though, so we should be okay. I don't know why I'm reading about this now, when this is not my goal, but this is kind of interesting and possibly important. Probably important. Create the event channel, add to the world during state creation. Oh, okay. Huh. Is that what we did? Derive default? I don't remember doing that. I don't even remember creating a event channel. Did that happen somewhere? I don't think so. I think it is using some kind of default implementation then. This is supposed to be easier to understand than the previous segments, because this seems actually harder. At least to me. Maybe I'm dumb and I don't think about things in the right way, but this seems harder to me. Oh boy. Get a mutual reference to your resource. In the receiver system, you need to store the reader ID somewhere. Okay, sure. So maybe this is happening implicitly for the UI events. And I don't have to worry about that. That's why I don't have a producer for event channels. But yeah, I'd have to implement a receiver. Okay, well that's kind of interesting. How often will I want to create event channels? I wonder, like outside of using it for UI events, because I'm already handling UI events with like the built-in stuff. I guess you would want to have like an event channel to handle like, I don't know. Actually, I'm not sure. What kind of other events might you want to have? Like, maybe if there's a lot of stuff happening in the game, like if an enemy gets hit, that creates an enemy hit event or something. Like, I don't know. That's not exactly what I was expecting. Arena config? I don't know, I'm getting distracted now, but when I think of arenas, I think of, you know, like memory arenas, like allocation. Is this not the same kind of arena? I get the feeling this is a different kind of arena. Yeah, I'm pretty sure that this is a completely different kind of arena. This is like the more typical usage. Like the room where the game is being played out. That's fine, I guess. So none of this really answered my questions. And that kinda sucks. Is there anything in state about this? Yeah, okay. Game stage. General and global section of the game. Alright. Oh god, I'm so sleepy. I don't think I can make it. I can't do it. I'm so tired. Oh, here, they explain all sorts of things. Huh, this one doesn't return a trans. Oh, of course not. It wouldn't. It's a shadow update. That makes sense. Okay, ay. Is a struct containing a dispatcher? Okay, well, that's kind of cool, but I kind of want to. Okay, so you can handle events on the handle event method. State event. It's an enum. Yep. Okay, I'm starting to wonder. I'm really starting to wonder if I'm doing things correctly at all. Maybe there is no correct answer. Maybe it's just kind of one of those, I don't know, those things where it depends on who you ask. Some people have opinions that go one way and some people have opinions that go the other way. I don't know. It's very confusing. Because I see, like, in the Pong example, they have a system that handles inputs. So, like, they don't use handle event. It just makes me wonder, why handle event then? Or if I'm supposed to use both. Because it seems like handle event it returns a trans, so it makes me think that it should be used specifically for, you know, handling state transitions, if anything. But then you can also use it for so much more than that, too, which is, yeah. I guess it depends on the kind of game you're making, too. Like, if it's a single state game, like that Pong example, then it doesn't really matter. You can just use a system for all your inputs. But yeah, that sure is annoying. Trying to figure out, like, what is the intention of all these different components that do the same thing, basically. Because it makes you wonder what you should, like, how you should do things. What is considered idiomatic for this engine? Alright, so they kind of address what I was thinking of here, but they also kind of just say, oh, well, we'll talk about that later, and then they don't. Or if they do, they don't. It's in some place here that I'd rather not, you know, have to search through because it doesn't seem. Oh wait, custom game data? Oh, this might be it. Yeah, look at this. This has multiple dispatchers. Okay, I think this is what I need. This is actually kind of complicated looking. As soon as you start throwing in lifetimes and generics, everything just kind of, you know, starts to look a little bit noisy, I have to say. I mean, it is certainly quite readable if you just sit down and actually read it, but just when you like look at this, it's not like your simple, you know, signature that is really easy to parse immediately when you see it. You kind of have to like sit down and think about it first, and sometimes my brain just doesn't feel like doing that, such as right now. But I probably will have to, because if I don't, I'm gonna regret it. Now, this isn't being particularly clear about how you would do this per state. Like, how would you do this only for certain states and not for every state? Oh, hey, here we go. We should not dispatch running. What does that mean? Is there a system called running? True to say we should dispatch running. Yeah, like that's the kind of thing that I'm not really sure about. So do we just register all of the systems up front? Maybe I should just read this page and it would make a lot more sense. Just, you know, putting it out there. That'd be probably a better idea than kind of reading the code and guessing at what things do. Alright, so far we've been using this supplied game data struct to handle our systems. This works well for smaller games and demos. Once we start building a larger game, we'll quickly realize we need to manipulate the system dispatch based on game state. Yeah, exactly. Or we need to pass data between states that aren't sync plus send. I read that in the wrong order. Which can't be added to world. The solution to our troubles here is to create a custom game data structure to house what we need that cannot be added to world. Okay. In this tutorial, we will look at how one could structure a paused state which disables the game logic, only leaving a few core systems running that are essential, like rendering, input, and UI. That's exactly what I would want. So they create a custom game data structure right here. Core dispatcher and running dispatcher. Okay. Fascinating. We also have a utility function for performing dispatch. Update. Oh, and then there's a running bool. I see. And if it's true, then it'll dispatch the other systems. Running dispatcher.dispatch. Alright, sure. Don't you have to define a different dispatcher then? That's what they're doing here, isn't it? To be able to use this structure with Amethyst's application, we need to create a builder that implements data in it. This is the only requirement placed on game data. Data in it? I don't see that here. I see default. There it is, down here. Okay. That's a pretty lightweight trait bound, I would say. So let's read through this carefully. Okay, so they use an arc thread pool, so it's important to know. Custom game data builder. Okay, it has a core, which is a dispatcher builder, and running, which is another dispatcher builder. We implement a default for custom game data builder, which just calls game data builder new, which, you know, that makes sense, right? Here's new, it just creates two dispatcher builders. That seems pretty standard. So yeah, this is that's our only constructor. Fun with base bundle. So they have bundle, and that's an argument. Dot build map error. Okay. With running. So base bundle must correspond to the core dispatcher, and running, or with running, must correspond to the running dispatcher. That would make the most sense to me. So it takes a system. Oh no, here's this crazy notation. I've seen this before. It has to do with higher rank trait bounds, and I still don't understand it. I know it's something that's covered in the Nomicon. I haven't. Well, I did read that section. I didn't really understand it that well, but yeah, that's a thing. Something to be aware of. And I probably won't have to worry about it. So with running, takes a system, a name, and dependencies, and just goes running.add. That's interesting, because they don't go like core.add or anything. So this running.add is adding systems specifically to this dispatch builder. I guess the core we'll use with base bundle, and we'll probably see it down here, because these methods are not, this isn't an impl something for custom game data builder, this is just impl custom game data builder, so someone is going to call these here. Okay, so they do a clone, huh? Alright, and then we get a pool. So data init takes, okay, it has a build method, that's the important part. And it creates a core dispatcher by calling self.core. Okay, and that's that core was one of our two dispatcher builders. With pool, and it gives it the pool, of course, which it clones. Right, and these clones are, this isn't, I think this is probably ARC. It's similar to RC. So these clones are very cheap. And they build. Yeah, and that builds the dispatcher. And they do the same thing with running. Core dispatcher.setup. They give it the world. Who calls those methods then? Someone has to call those. Oh, down here with base bundle. Ah, there we go. Yeah, so this is akin to what we do in main here with the game data with bundle. Yeah. Because this is a regular old default game data builder, and we with bundle it a whole bunch. And they also have a with running, and they give it systems to register specifically for if you want to only run certain systems in certain states. So that's interesting. Looks like ideally we want to make sure that certain, like the UI bundle and stuff like that, these things are kept the same. But because these are pretty standardized. So I do want to do this. Definitely want to do this, and I'm gonna have with. I'm probably gonna have more than just like a with running. I'm not going to be doing a Boolean flag. That's not going to be good enough because a Boolean obviously only has 2 values. We're going to need to use a sum type here with more variants. So that shouldn't be too hard. Yeah, so instead of saying true to say we should dispatch running, we're going to have to say, like, I don't know, dispatch mode, whatever, say main menu, for example, or dispatch mode, custom game is what we're going to pass in to here, and then it'll, instead of doing a check if blah do this, it'll just do a match instead. That seems like the pretty simple way of doing things, actually. Yeah, so that's the general idea of what I'm going to do. This is key. This entire page is key. Custom game data. Remember this. In fact, I don't have to even remember this. Why? Because it's on video. Huh. I don't even have to use my tiny brain to figure that out. So yeah, there we go. It seems simple enough. Just set up the dispatchers here, and then give the arc-thread pool clones, and then create a custom game data with the 2 dispatchers. That's really simple, and it will probably work quite well. So yeah, that's probably going to be it for today. Actually, I'm kind of tired and I don't really want to do much more, so yep, I think I'm just going to leave it there.